So I'm really excited to introduce Markus Drouven, and he's from the National Energy Technologies Laboratory. And as you may know, and by the way, I'm Deb Agarwal. I'm the NAUI Deputy Task Area Lead for Modeling and Simulation. And as you may know, we've been working on some modeling and simulation infrastructure for NAUI that we'll look at the process level, enabling modeling and simulation there. And so that's based on a toolkit that had already been developed in power issue problems. And the project that Markus is going to talk to you about is another place where that toolkit is being used, and that's to look at produced water. So we felt that was of interest to the NAUI community, both because it's a look at some other uses of the toolkit, the same toolkit that we're building on, but it's also an opportunity to learn about a related project, which is, we think, of great interest to the NAUI community. So thank you all so much for attending. As Megan already said, feel free to put questions in the chat. We'll also leave plenty of time for Q&A at the end of the session. So with that, I'm going to turn it over to Markus.
All right, thank you for that kind introduction. So I want to talk to you about an exciting new DOE initiative focused on produced water optimization today, something that we're calling Project Pareto. Right from the beginning, I want to stress that this is a very collaborative project that involves DOE's National Energy Technology Laboratory as well as Lawrence Berkeley National Lab. Now, before I get into some of the project material that I prepared for today, I was encouraged to say a few words about how I ended up getting into the produced water world, and so I wanted to just start with that. So the first time I heard about produced water was actually not until graduate school. I had gotten some funding from the National Science Foundation to build optimization models for a number of things related to oil and gas. And it turns out that one of the members of my PhD committee was a professor by the name of Megan Motter, who many of you will recognize. And so Megan had done some great work related to produced water. And so I thought, well, I might as well just take a look at that field and see what I can contribute. And I was very quickly fascinated by the complexity of produced water, and I'll speak to that today in my talk, and discovered that there was loads of opportunities to improve things and to make a potential or have an impact, a potential impact, even as a graduate student. So I did my work, published a paper, and then moved on to other topics, worrying that I wouldn't have a chance to get back. But fortunately, I was wrong. After I graduated, I took on a role in the private sector, joined a company called EQT. They had become the largest natural gas producer in the US at that point and were very active in terms of shale gas development. And for that reason, had a lot of exposure to produced water. And so some of my colleagues and I, we ended up developing and deploying really an optimization-based scheduling solution specifically for produced water. And that project turned out to be incredibly impactful. We had reason to believe that this little piece of software was going to save the company somewhere between $25 and $35 million a year. And you don't have to take my word for it. EQT was very vocal about this. They put this in their investor presentations to Wall Street, highlighting the fact that it was really an optimization model and a mathematical programming algorithm. So using the right terminology even to emphasize that this was really making a difference in how the company was managing water and realizing some of the cost savings I just mentioned. So shortly after I joined NETL late last year, I was quick to advocate that we launch a new research portfolio dedicated to produced water optimization, because I'd seen firsthand what the technology could do, and I was convinced that DOE had a great opportunity here to make it more available, more accessible to the produced water community. And so that's really how this project was born. Now, looking back at almost a year of exposure to the produced water world, it's remarkable what's happened. I want to speak to a lot of the changes that have transpired very recently, but I also want to stress that there are a lot of challenges that remain. And I say that because those are oftentimes really intriguing research opportunities where I personally am hoping that we'll have more researchers get involved in coming years. But first, I recognize that not everyone in the audience may have come across produced water before, and I want this to be an inclusive talk. So I want to take a moment and provide a little bit of context to answer questions like, what is produced water and why is this interesting? What do companies do with it? So I'll just start with that. So it's relatively well known that oil and gas development, especially from unconventional plays, the shale resources, requires lots of water. And it is true that nowadays, hydraulically fracturing a single well can sometimes need more than 1 million barrels of water. And just to put that into perspective, 1 million barrels of water, that's about 63, 64 Olympic-sized swimming pools. But it turns out that companies these days, they don't just fracture one well. They typically go after 5, 10, 15, or even 20 wells at a time. And so the water demand can be as much as 1,200 Olympic-sized swimming pools. It really is a lot of water that the industry needs for development. What's not so well known, however, is that once we start recovering hydrocarbons from these formations, natural gas or oil, we co-produce large amounts of high TDS water. And that's what's called produced water. Now, produced water is really a mix of the water that was injected initially during the development process and a mix of that and so-called formation or ancient water that's always been present in the formation. How much water companies produce is actually something that varies significantly from one area to the next. And so if we look at this map here, what I'm showing are really two different blue circles. The light blue circles indicate how much water oil and gas is expected to need for development in certain areas. The dark blue circles indicate how much is projected to be produced over the lifespan of some of those geological plays. And what you'll see is that in some areas, notably the Marcellus or the Eagle Ford, the industry will likely need more water than it produces. But in other areas, and the heavy hitters, the Delaware Basin, the Midland, the Bakken, the Permian Basin, we find that we'll likely get a lot more water out of the surface than we inject into it initially. And so the first takeaway message that I want to leave everyone with is that across the US, oil and gas actually produces more water than it consumes. So that's one sort of reality that I want us to hold on to. So now let me just say a few words about what do people do with it. So water comes out of the ground. What are the next steps that we typically see? So the sort of predominant way of dealing with this water for the longest time was to send it to so-called disposal facilities and inject it deep underground. And it doesn't sound like a great practice, but it worked for a while, and it made sense because produced water was a waste byproduct. And it turns out it's actually relatively cheap in many places. But then within the past 10 years only, and I would actually say this took off in the past 5, now companies realized and said, well, we're producing water, but as an oil and gas organization, we also need a lot of water for development. So why don't we just reuse our produced water? It's called completions water reuse because the water is used for the well development, the completions process. And this has really become a lot more popular. Companies try to realize it as often as they can because it's also a relatively cheap way of dealing with water. And then there's one other option, and this wouldn't be a NAWI seminar without talking about treatment, and that is to treat the water. And in principle, this is possible, although we'll talk a bit more about the challenges associated with that in a second. The reason it really hasn't taken off is because it's very expensive. And so I'll get into that a little bit more in a second. But I always feel that when I talk about produced water, it's important to also talk about fresh water because there's a clear relationship between these two water sources, which is, especially from an oil and gas perspective, for the longest time and until this day, oil and gas organizations still rely on fresh water to meet their demand. They do so because it's sometimes, in certain areas, it's abundant, but really because it's actually quite affordable. But it is a bit of unfortunate considering that we can use fresh water for all kinds of wonderful things aside from oil and gas development, to drink water, to feed animals, to grow crops. And so there's always this competition, right? So every barrel of water that gets used for oil and gas is a barrel that's not available for something outside of oil and gas. The other way around, every barrel of produced water that gets reused is a barrel less of fresh water that is consumed somewhere. So now let me circle back to treatment, because treatment could be the link between these two sources, clearly. If the industry decided to treat, and by that I mean desalinate the water, we could replenish freshwater aquifers. That's an option. The industry could technically use it for its own demand too. But the more intriguing avenue that's sort of gotten a lot of attention recently is this idea of using treated produced water for what's called beneficial water reuse. So use it for the irrigation of crops, use it to replenish aquifers, use it to extract critical minerals. There are a lot of avenues that are currently being explored. The only thing we have to keep in mind as we talk about this is that desalination means we'll be left with concentrated brine. That too has to be dealt with. So disposal will likely continue to be a part of the produced water management mix. But the point that I'm trying to make is if you look at the options for managing produced water here, it really doesn't look like a traditional chemical engineering problem. It becomes a supply chain optimization problem. And so that's the angle that we're exploring with Project Pareto, and I'll say a little bit more about that in just a minute. But first, let me just talk about some of the things I mentioned earlier. This is a fast-paced domain. There are a lot of things changing. So let me talk about some of the changes that we're seeing on the horizon. So one is that in the coming years, we'll likely have more of this water to deal with. And I don't want to get into the details of that, but the reality is that for every barrel of oil that gets produced, there will probably be more water coming out of the ground. So that's one thing that's going to change. The second one, and this could be a major shift, is that disposal capacity, the way it's been available in the past, will likely not become as accessible anymore. The formations that organizations have been injecting into are starting to become full. They can't take any more water. Also, produced water disposal has been associated with seismic events, so earthquakes. So for a number of reasons, that option is going to become less of a path forward. It's not going to go away, so I'm exaggerating with my red cross here, but it is going to become less available. The other issue that we're seeing is that when oil and gas prices are low, as they are currently, the industry has little incentive for drilling and fracturing lots of new wells, meaning oil and gas has less demand for water. That means there are less opportunities for reusing produced water within the industry. And so that option is slowly fading away too. And so if you look at it from that perspective, it would seem that desalination, the treatment of these waters, is likely going to become a necessity. And that's what we're hearing from the produced water community. Desalination treatment will likely become a priority in the near future. So let me talk a little bit more about why that is interesting and why that is going to be challenging. So for one, now, I'll just point out that the oil and gas sector really hasn't had to desalinate a whole lot of produced water in the past. So it's not like there's a great track record we can go off of. Two, produced water is incredibly challenging to treat. And it's not just because of the TDS concentrations, but that has a part to do with it. Concentrations, by the way, can range from anywhere between 30,000 to 300,000 milligrams per liter. So really high TDS water. But on top of that, it turns out that the quantity and the quality of water that comes to surface can actually vary not just from one area to the next, but even over time. So sometimes companies will start producing, moderate TDS water, and then a couple years into the process, they're looking at really high TDS water. So it's not just that it's costly and energy intensive to do, it's also really tough to figure out which technologies are going to work in a given area at a given time. There is likely no one-size-fits-all treatment approach for produced water, and that does make it quite tricky. And then there's one other factor that I personally feel is most often overlooked when it comes to produced water treatment, and that's the highly distributed nature of the production that we're dealing with. Because it's not like there are 5 or 6 locations across the US where this water is coming to surface. No, the reality is there are thousands upon thousands of well sites spread across, oftentimes vast areas that are all bringing water to surface relentlessly every single day. Sometimes just a couple barrels a day, sometimes a couple 100,000 barrels a day. But that's why, even though the community is starting to look and seriously think about treatment, we have to recognize that one of the major challenges is to make it work at scale from a systems perspective, to understand where would we place treatment, how would we operate it, to make sure that we're really seeing the big picture here. And so that's exactly what Project Pareto is tapping into. Our vision for this initiative is to develop an optimization framework, essentially a software program, that can help organizations better manage, better treat, and where possible, beneficially reuse produced water from oil and gas. And so this framework that we're calling Pareto is meant to help with a number of things. For one, there's the build out of produced water infrastructure. So helping companies see where could it make sense to build a pipeline? How big should I make that? Does it make sense to invest in a storage facility just to balance supply and demand? But Pareto will also help with the mere coordination of water deliveries, figuring out where do I take water tomorrow, a week from now, or a year from now. As I'll explain in a little while, that's not an easy undertaking. But we want to go beyond that. We want Pareto to help with the selection of treatment technologies that can work. But again, also look a little further than that. We want to see, now, where could we place treatment facilities in the context of these networks? How big would we make them? and how exactly do we operate them? And then there's the beneficial reuse opportunities that we want to look at. So Pareto will be designed to help identify those, whether it's opportunities for the extraction of critical minerals or the irrigation of crops. We want Pareto to help us identify, recognize those, but again, go beyond that. Look at what sort of supporting infrastructure is going to have to be in place to realize those opportunities, to get treated produced water or concentrated brine to whoever may have an interest in it. Now, everything we do as part of Project Pareto will be continuously reviewed by a broad stakeholder coalition, and I'm going to talk a bit more about that group a little later. I also want to stress, though, that we're really committed to conducting a number of case studies with industry and other partners, primarily to verify the framework, but also to get the word out that this is an exciting tool that will become available to the community. And our vision is that if we're successful, then Pareto will help not just oil and gas, but also allow other industries to explore opportunities for making use of treated produced water. So with that, let me sort of say a few more words about the scope that we're aiming for here with Pareto. How would we, apply, or how do we expect to apply the framework once it's, fully available? So the idea is that with Pareto, you look at an active oil and gas development area. So you'll consider all of the well sites that are bringing water to surface day in, day out. You look at all of the completion sites that really present opportunities for reuse with minimal treatment, but also consider all of the disposal sites where it is possible to de-inject the water when that's the only or most cost-effective option. What we want to add to that scope, though, is consider candidate locations for placing treatment facilities, where we can consider a pool of technologies that might make sense, because that is ultimately what may give the oil and gas community access to potential water end user industries, including agricultural stakeholders or mining companies. And that's ultimately what might allow us to explore beneficial reuse opportunities more carefully. But really, the big picture idea is that we need to look at this from a network perspective. We want to consider all of the options that are available to organizations there and use the program to extract from that, which connections make the most sense for a given company in a given area at a given time. And through that process, we're hoping that Pareto can help oil and gas and other industries make better and faster decisions really about what to do with produced water. So let me tell you a little bit more about the framework from an inputs and outputs perspective. So what do we feed into it, and what can we expect to get out of it? And so I'm not going to sugarcoat the fact that, there's quite a bit of data that's going to go into this, right? Pareto needs to know how much water is coming to surface and where. Ideally, what quality water are we dealing with? We need to instruct the program and say, what sort of transportation resources we have in place for moving water, which, by the way, is currently one of the most cost-intensive aspects of produced water management. It's just moving it from place A to place B. And some organizations rely on fleets of water hauling trucks. Others have extensive pipelines in the ground. So that's information we have to provide the program with. We need to provide locational information on disposal sites and reuse opportunities and capacity and demand forecasts, as well as whatever cost assumptions that we're operating. So there's a lot of information that goes into it on the front end. But in turn, what you can get out of Pareto are a lot of, we think, very valuable and specific insights. So Pareto will tell you where and how you can build out your infrastructure, where to place treatment and storage facilities, how to build out your pipeline network, how to coordinate the scheduling of your water deliveries. Pareto can help you identify blending strategies so that your treatment facilities don't become overwhelmed with poor quality water. It can predict how much fresh water you'll likely need to consume going forward, or how much produced water you'll possibly have to send to a disposal facility. And we can look at all of that from an economic perspective too. Now, clearly, these outputs will depend heavily on the inputs. That sort of is a given, but they'll also depend on what objective you specify when you run Pareto. And this is where you'll be given options. You can say, I want to use this program to just optimize my cost. I want to understand what I can do to get my costs down. Or you could say, I'm really interested in understanding what I would have to do to maximize the amount of water that I'm reusing. Or you can say, I want to do a combination of the two. It'll be entirely user specific, and that's actually something I'll try to demo in just a slide or two from now. But first, let me say a couple more words about the workflow that we're envisioning, and I also want to address some of the most common questions we get about the program and the initiative as a whole. So what the project team and I are really committed to right now is developing the program itself. right? So we're developing the math and the logic behind the scenes that's going to make this tool work. So we're coding in a whole bunch of objectives that companies might want to pursue, and we're coming up with constraints that we have to consider and things along those lines. Now, to run the program itself, you have to read in the data that I talked about on the previous slide, and you'll get the results that I highlighted earlier too. But what I really want to stress here is that input data is not stored within the model. Okay, it goes into it, results come out of it, but the model itself is not going to soak up any of the data. And I say this because that's one of the most common questions we give about Pareto is this just a data vacuum or what are we talking about? And that's not the case. As a matter of fact, organizations that want to use Pareto will be able to download, to configure, to run the system, the program on their systems locally without DOE involved. So for our industrial audits, I just want to clarify that. You don't send DOE any data. DOE doesn't get to see your results. All of that stays with you and is owned by you. We're really just looking to make the underlying technology available to the community. Speaking of which, the program will be made available free and open source under a 3-clause BSD license, which means that you can really do with this whatever you want. You can use it internally free of charge. You can commercialize it and sell it to other parties, and DOE will have no issue with that. The one disclaimer that I will add here, though, is that this tool is not really expected to replace detailed engineering and analysis. It's meant to be a decision support framework. So not pushing anything out, but really just adding to the tool set that the community has at its disposal. So let me say a few words about the project timeline and the deliverables that we're aiming for. So it's a 3-year project. We decided to split it into 3 distinct phases, every phase taking up exactly 1 year. Phase 1, year 1, we're entirely focused on what we call water management. So we want Pareto to capture current industry best practices and infrastructure solutions that are already in place and verify the framework, make sure it does what it is supposed to do, and find ways to improve upon current best practices. Now, by year 2, then, we want to really focus on water treatments and make use of some of the great tools and the libraries that NAWI is developing. Plug in some of the detailed treatment models, incorporate them to our network optimization framework so that we can then look at, okay, where does it make sense to deploy which treatment technologies, where do those facilities go, and how do we operate everything from that perspective. And that'll then allow us, it'll really set us up for year 3, where we can more carefully explore beneficial reuse opportunities. Now, in terms of deliverables, there are really 3 things that we're aiming for here. 1, every year of the project, we will make software available. So that's something you can count on. 2, we're committed to conducting case studies with industry and other partners, again, primarily for verification. But 3, we're also looking to summarize our findings and share best practices with the community as we go along. So expect to hear more on that in sort of the coming years. One thing I just wanted to circle back to is the stakeholder board that we're forming as part of this initiative. We're really, when we started to put this together, we're really aiming for a full representation of the produced water community. So you'll find we have on this board upstream operators, midstream companies, technology providers, industry associations, regulatory agencies, and nonprofits. So we're really trying to bring together the community and looking for them to guide us along the way to make sure that we're focusing on the right topics. So with that, I can take a quick break and just see if there are any questions. If not, that's okay. I'll just go ahead and do a demo of the framework and show you what Pareto can already do and where we're looking to go next. But I want to make sure that I'm not overlooking any burning or pressing questions at this time.
Thanks so much, Markus. Given that a few people joined late, it might be worth reiterating sort of the relationship between Pareto and NAWI. And there are no questions in the chat as of now. So you can go ahead on the demo. Yeah, so I think, Deb, you phrased it perfectly at the beginning of the session, which is that Pareto and NAWI, I think in many words, are going after similar goals. Pareto is just much more specialized and focused on produced water as a water source specifically. And we're really looking at a lot of the logistical, the supply chain planning aspects there. The underlying technology is very much the same. So NAWI's Proteus Lib team, which is developing a library of water treatment process models, is making use of a framework called IDEAS. We're making use of that here too. And I'll actually speak to that a little bit later, but the beauty of this is that
next year, and actually as of right now even, Pareto and the NAWI Proteus lid tools are fully compatible. And so next year, when we're looking at treatment specifically, we'll really be able to leverage that, but the foundation is very much the same. So that's one of the reasons why I'm able to share a demo with you about 4 months into the project. Otherwise, that would have taken us a couple more years to get here. All right. Deb, you said no questions, so I'll just go ahead with the demo.
That's correct. Go ahead with the demo.
All right, wonderful. So as I go into the demo, I just want to preface this with a couple of disclaimers. For one, this is an entirely made-up problem. We call it our sandbox case study. So it's motivated by Permian Basin, by real operations, but it is a fully hypothetical problem that we use internally for testing, but also to showcase what it is that we can do. And so the starting point of the case study is the schematic that I'm showing here. A lot of complexity, I realize, but let me walk you through it. So the idea is this is a produced water system that consists of a whole bunch of production pads. So these are places where produced water is coming out of the ground. We're representing those by these green circles with black numbers in them. For this case study, we're also assuming that a whole bunch of pipelines have already been built and laid out in the ground. Those are shown through the solid black lines. The pipelines connect our production assets to the so-called disposal facilities as well as our treatment facilities. So everything that's shown with the sort of solid surrounding a solid lines, those are what we're assuming are existing assets that are already in or on the ground. But for the case study, what we're assuming, and which is very typical, is that we want to consider a whole bunch of options for building up the system, for moving ahead. So every dotted line that I'm showing here is an option for laying out a new pipeline, a possibility that we want to consider. We're also considering the possibility of building additional injection facilities or constructing storage sites or things along that nature. And then finally, for this case study, we're also assuming that we've got a couple of, it's an active oil and gas development area. So we're assuming there are some completion sites where there may be a demand for water. So an opportunity to reuse water directly within this area. And so this schematic is sort of our superstructure, right? It contains all of the options that we want to consider. And in just a few slides, we're going to see what Pareto proposes that we do with this. But first, let me say a couple more words about the setup of the case study. So it's a brownfield project, meaning there's already some infrastructure in place. We decided to just optimize this for a one-year planning horizon at a weekly resolution. We made a whole bunch of cost assumptions here that are, again, made up, but representative of typical activities in the produced water space. There is one input that I want to talk about here, and that's highlighted on the right, this chart. It's the produced water forecast, and this is a really important input to Pareto. It basically shows us how much water we're expecting to bring to surface in this area over the coming 52 weeks across our 20 or so assets. And it's a really important input because by design, Pareto needs to find a home for every barrel of water that is coming to surface. And so again, we'll be able to look at what exactly it is proposing to do. You'll see a lot of that is driven by, again, how much water is coming to surface and where. So when we run the optimization program itself, what it's going to do behind the scenes is going to look at every one of these options here, rigorously evaluate those, and for a given objective, try to extract whatever solution or infrastructure configuration makes the most sense. So initially, we're going to run a scenario where we're just going to optimize for cost. So we're basically telling Pareto, look at this system and tell me what does a cost optimal solution look like. And so that currently takes about 60 seconds or so to end up with a half decent solution. And when we run the program, what it really spits out on the back end is Pareto tells us exactly where it wants to build new pipelines, represented by these solid green lines, where it does not want to build pipelines, how much piping capacity to provide along those lines, whether or not we should invest in additional injection capacity, if we should construct a storage site, how much treatment capacity to provide, and where exactly we can take treated produced water to. So what I want to leave you with is that even at this early stage, the infancy of Pareto, it can leave us with some very specific insights that we believe will be valuable to the produced water community. Now, if I clean up the solution a little bit, what you'll see is that we've extracted one particular configuration from that infrastructure, and we can actually read into that a little bit. So for our cost optimization objective, Pareto is basically telling us, you know what, focus on the peripheral build out of the system, so to the sides, to the east and to the west, but there's really no need to interconnect these two systems. We'll just keep them disjoint now, at least for a cost objective. That seems to make the most sense. The other thing that we can look at as part of the solution is the scheduling side. So I mentioned one of the major inputs into the program is this produced water forecast. How much water is coming to surface? And so that's what I'm showing in blue here. Well, Pareto looks at that and tries to find a home for every barrel of water. And it's going to prescribe very specifically which destinations that water should be sent to and when. So as I blend in the solution, what we can interpret here is Pareto's telling us that between weeks 1 and 12, we should send about 100,000 barrels per week to a completion site. So an oil and gas development area where we can reuse with minimal treatment. Between weeks 22 and, 36, it's saying we should send a little less than 200,000 barrels per week to another completion site. And so as I'm blending in the solution here, where we're seeing that the program is telling us exactly where it wants to take water to at which point in time. And at the end of it all, every barrel of water is fully accounted for. So this in of itself is a very valuable output to practitioners. It also allows us to really tally up key metrics so we can look at, well, for this solution, how much fresh water are we sourcing? How much produced water is going to disposal? Am I running any trucks in addition to operating pipelines? What does my overall reuse rate look like? Which, by the way, in this case, for this domain expert is intentionally low. So 40% is really well below what industry is currently doing. So that's one solution. But the beauty of Pareto, at least in my opinion, is that the framework is set up so that we can do a lot of great scenario analysis very quickly. So what we can do now is say, well, that's an interesting solution, but let's say I don't care just about cost. I'm really interested in understanding what I could be doing with the system to maximize the amount of produced water that I'm reusing. And so we'll be optimizing the same system with the same data. We're just changing one line of code and saying, my objective is now maximize reuse, please. And so 60 seconds later, Pareto will give us, again, very specific insights into what that could look like. It'll propose where we should build pipelines, how big to make them, where not to invest in assets, how much treatment capacity to provide, and how to connect that to reuse opportunities in the area. So again, if I clean this up, the point that you'll see here is that we're optimizing the same system, but for a different objective, the infrastructure configuration that we're identifying is very different. Qualitatively, what the program is telling us now is don't focus so much on a peripheral build out of the system, to really make sure that they're interconnected so we can get water to where it might be reused very quickly. And so again, we can tally up key metrics. We can quantify scenario by scenario, side by side. Well, how much fresh water am I sourcing now? How does that compare to my cost solution? Am I disposing more water? What is happening on the trucking side of things? So it's really a very, I think, elegant way of quantifying different options that companies might be thinking about. So just to sort of round off, where we are right now is that Pareto can already do a couple of exciting things. It can help us with the placing of pipelines, the routing of pipelines to extend sizing. It can help us understand how much capacity we might need for storage or treatment or injection activities. And it can really help us coordinate deliveries in a given area. But we have big plans for Pareto, and we don't want to just stop here. But going ahead, we want the framework to be able to predict how water quality might propagate through a network, how it propagates through a pipeline system. We want Pareto to help us understand what treatment technology could make the most sense, where we place those facilities in the network, and then from there, identify reuse opportunities. So that Pareto can tell us, listen, I've looked at your system, and based on the information you've provided, you might have an opportunity to extract lithium from your water at commercial scale. And so Pareto can provide some guidance into how that could be done and what sort of infrastructure would have to be in place. So hopefully there will be a lot more to come on this in the coming months and years. One other thing I wanted to just touch on is we're really committed to trying to make Pareto and turning into a user-friendly application. And I'm very glad that we've got our colleagues at Berkeley working on this. They have a ton of experience in this area. These are just sketches and mock-ups, so to speak, of the interface that we're aiming for. But we're currently thinking that Pareto can be turned into a browser-based application. You'll be able to read in data from your internal databases or pre-formatted spreadsheets. You can easily natively create scenarios in the application, specify different objectives, modify parameters, whatever it is that you want to explore, then run the program and directly from within the application, compare different solutions side by side. So you can say, well, I'm curious, base scenario 1 and 2, how do those changes impact my reuse rate or my disposal volumes or my costs or really anything along those lines. So this is something that's really important to the project team as a whole and to our stakeholders. So I look forward to sharing more with this, on this with you sometime later next year. The other thing I want to stress
so Markus,
is that, sorry.
Actually, before you go on, I noticed on your prior slide you have optimization settings. There was a question about optimization methods. I mean, you've talked about that I can, set my optimization goals. What are the other things that users will have access to customize the optimization?
Yeah, it's a valid question. Again, I mean, given the fact that we're making the program available free and open source, I would argue to say that you can change anything. You'll be able to peek behind the curtain and make any changes that you'd like. Now, natively within the application, especially under this category here, optimization settings or setup, you'll be able to select objectives. You'll be able to set time limits. You'll be able to select algorithms that you want to use for exploring the feasible space. So I think we're just going to turn to our stakeholders there for what it is that they're interested in doing and strike a compromise between giving people lots of options, but also making it so that you don't need a PhD in optimization to run Pareto. That's one of the things that's very important to me. So behind the scenes, you can change anything and everything. On the front end, we'll give you some of the most popular options.
Thanks so much, Markus.
Sure. So just on that note and along those lines, I just wanted to reassure everyone that, for Pareto, we're leveraging a really mature software development, testing, and release process. And this is really coming through our colleagues at Berkeley who have a ton of experience with this. So the software will be released on GitHub. So we'll be able to push changes. You'll be able to download the latest version as we make improvements. The initial release is currently targeted for later this year. So you won't have to wait very long to just take it for a spin. And if you're interested in testing it well before then, please reach out. We're always looking for beta testers. And I just want to reassure everyone that the release will come with supporting material. So we'll be supporting documentation. We'll have test problems, the repository, and we'll even offer office hours starting early next quarter. So if you're interested in just experimenting with the tool but need some assistance, we're there for you. The release of the software is really a major deliverable of the project. So we're taking this part very seriously. A couple other things I just wanted to touch on to round off the presentation. One is case studies. So I mentioned this early on. It's very important to us to do case studies. We see that as an opportunity really to verify the framework, to make sure that it does what it is supposed to do, but along the way, to also raise awareness for the value of optimization tools in this space. Again, I mentioned early on that I've seen firsthand what optimization can do here, but not everyone has had that opportunity. So wherever possible, we want to use these case studies to highlight and quantify the benefits of using optimization for decision support on produced water systems. So we'll try to benchmark actually, without optimization, here's how an organization manages their water. Here's what the tool is proposing. How do those two solutions compare? And again, wherever possible, we're going to try to demonstrate that this sort of optimization approach is not only going to help on the cost side, it can also realize some important operational, environmental, and safety benefits. So what I'm showing here are not targets by any means, but they're examples of the resolution of results that we're aiming for here. So hopefully, we'll be able to share more on that too sometime early next year. I did touch on the stakeholder board briefly, just wanted to follow up on that. Again, we were just in the process of forming this open stakeholder board right now, aiming for really a full representation of the produced water community. Want to get people with different professional backgrounds and geographical focus areas into the stakeholder board, where the main goal is that this board will help us guide us along the way and make sure that we're addressing timely and important challenges. It's an open board, so if you're interested in playing a more active role in this initiative, please reach out. We think it's a great opportunity to present the project team with challenge problems, to highlight certain topics of interest that you would like us to look at, and frankly, really shape DOE's medium to long-term strategy when it comes to produced water. So lots of reasons to at least give this some thought. And again, it's very important to us. It's a cornerstone of the project is forming this board. I'm glad to say that we're not doing this by ourselves. We've got some wonderful help. Lisa Henthorn, who some of you may know. She's the former president of the Produced Water Society, has agreed to serve as our stakeholder coordinator. So she's really going to facilitate the back and forth with our collaborators, with our stakeholders across industry, academia, and the government. So a wonderful person to work with, and please do reach out to Lisa or myself if this is something you'd like to learn more about. So just to round out the talk and leave plenty of time for questions, one of the reasons why I'm so excited about this initiative is we're really aiming for a broad set of deliverables. As I mentioned earlier, every year of the project, we will make software available free and open source. We'll be conducting case studies, sharing our findings with the community to the extent that we can. So that all is exciting. The project is directly aligned with DOE's mission. We're trying to understand what can be done to transform produced water from being a waste into a valuable resource. And so I'm hopeful that we'll be able to continue this work beyond the first 3 years. It's also fantastic to see how this is a project where we can leverage many of the great capabilities that already exist within the department, and specifically at NETL and Berkeley. We already touched briefly on IDEAS, the modeling power systems optimization framework. So that's really at the foundation of Pareto. The Pareto is also a chance to take those treatment models that now we're developing, plug and play them into the framework, and see how that can help us on that front. And so now just to visualize that, so the way we're seeing all of this come together is Pareto serving as the foundation specifically for produced water optimization, but then taking the more general purpose NAWI treatment models, plugging those into the framework, and leveraging IDEAS to really explore some of the beneficial reuse, the extraction process opportunities that we're quite interested in right now. So yeah, all in all, we're really hopeful that Pareto will be a success and help the oil and gas and other industries, frankly, to find ways of making use of treated produced water. And so with that, I just want to recognize the full team. I did all of the talking today, but there really are a lot of great minds behind this. I also want to acknowledge our support from the Office of Fossil Energy and Carbon Management. And yeah, with that, I'm happy to take any questions that may have come up.